for watching this video on how to make electron configurations. Basically, what an electron configuration is code on where electrons are in an atom or an ion. Today, I'm going to show you how to do that for an atom. But before we get started on the code, what we need to do is put some things on our periodic table to help us. The first thing that we want to put on the periodic table is the energy levels. You're going to find the energy levels are the rows. That's going to be real helpful to us in order to create our first number. The second thing is the orbital blocks. This first one here is our S block. This one here is our P block. And we're going to take this helium way over here and put it there. Okay? The next block, the transition metals, those are the d orbitals. And this bottom one, which gets inserted in there, this is the F block. The next thing that we want to do is to just number the columns. Okay, so in the S block, this would be column 1 and then column 2. In the D block here, 1, 2, 3, and so on. Over here in the P block, 1, 2, 3, 4, 5, 6. And in the F block, we're going to go 1 to 14. So that is a periodic table all kind of marked up to help us out with these electron configurations. So let's take an example. But before we do that, let's talk about these number letter numbers. First of all, this first number here, that represents the size. It's also going to be highly related to these numbers here on the side, okay? So for S orbitals, that number, the size, is the exact number that's on the side of the periodic table. So for 1s, this would be right here. The S stands for the orbital block. So this means the S block. The 2 in the upper corner represents the number of electrons. That would be represented by the column numbers. Okay? So let me do an example so you can get a really good feel on how these number letter numbers work. All we really have to do is read the periodic table like a book. So we'll start with the first row, go from left to right, and then we'll go to the second row from left to right. Let's do manganese. Manganese is number 25 here. So we're going to read our periodic table like a book. So let's start up here, up at the top, with the 1. I am trying to get to 25 electrons, but we've got to go from 1 to 25. So I'm just going to read the periodic table like a book. Okay? Our first orbital is going to be row 1, S. 1s. And if I look in there, I've got 2 electrons in there. That's definitely, I'm going to have to use those to get to the 25. So the superscript is the number of electrons. Okay? Now I've gotten through this first row, and that first row is finished. So now I'm going to come down to the second row. The 2 is going to stand for that second row. And if you look at it, I've got 4 electrons total in there. That's definitely, I've got to get on my way to the 25. That's also an S orbital, and I have 2 electrons in there. If I continue reading my book, I now get to the 2 P orbitals. I'm going to go ahead and get all the way through there. I'm not to 25 yet. So if you count those up, I've got 6 electrons in those P orbitals. Now I'm going to go to my next level. Now I've got 3s. And if you look at it, I've got both of those. I haven't hit my manganese yet. I'm going to read this like a book, go all the way across, and now I'm at the 3p electrons. And I've got all 6 of those. Still not up at 25. Now I'm just at 18. Now I'm going to go to the 4s level. If I look at that, now I've got 4s, and I've got both of those. Now, when I get to the d orbitals, instead of being 4d, this one's going to be 3d. The reason for that is because of the size of those d orbitals is not at the 4 bigger level, it's at the 3 smaller level. Even though these have more energy, they're just smaller. And we've got to take that into consideration. So for the d orbitals, you'll always want to subtract 1 from that row number. So for the d orbitals, d, you're going to take the row minus 1 in order to get that first number. So for this one, we've got 3d, and then I'm just going to count over. This is the block that I'm in. 1, 2, 3, 4, 5 is where that is. So I've got 5 electrons in that d orbital.